So thank you for coming. So my name is Mateusz Piwek. I'm a software developer, and also it has happened that I'm enthusiast about the software development and the technology in general. So today I'm going to talk to you about booting Linux, but in special way with MicroPython. And I have the question: does anybody of you has been doing something with MicroPython? So, okay. So MicroPython in general, it is the word of the electronic devices. So in MicroPython we have a lot of small microcontroller boards that can be used to drive different sensors. So for instance, it can be used to read the to make the measurements such as temperature, humidity, and then these measurements can be sent over network or somehow processed and so on. And so this is why the MicroPython was developed. And in another hand, we have the Linux. And so we have the fully fledged operating system. And this presentation will be actually about these two sides. So I will be talking about MicroPython, but also about Linux, specifically about the booting process. So let's start with the definitions. So MicroPython is Python re-implementation. It was released, I think, 2012 or 14, but and it was created to make possible to develop the programs for the microcontrollers. Like before MicroPython, actually the most common language to develop the software for microcontrollers was C. And the creator of MicroPython has came up with the idea that it would be good and efficient to bring Python to this world. So here, with MicroPython, we can develop software for very tiny computers that have the CPU, like with the one core, with 100 megahertz of the CPU speed, with very little RAM. So in general, these are the computers like from, let's say, 1980s, 1990s. And these are small devices. So like here is to compare the post stamp and the micro SD card. So these are very small devices, and also these devices are very power efficient. So it can work on the battery. In most cases, the devices have the Wi-Fi network. They have the Bluetooth. So in general, there is the networking capability. So it is like interesting device to build the project. And also there is more and more than HIE for such devices. And the second definition is the Init system. So now if we take a look on much stronger computers that are the laptops, PCs, servers, and so on, those computers run fully fledged operating system, and this operating system needs to have the Init system that is responsible for bringing up services. So in general, Init system is responsible for preparing computer to be used by user. And when it comes for the Internet of Things, also everybody knows for sure this device. So this is the Raspberry Pi, and this is also a very nice board that can be used to run Linux, and it has so-called GPIO ports, GPIO pins that can be also used to talk to devices such as sensors, small displays, and so on. And and when it comes for the Init system, we are speaking actually about the Unix world. So I don't know how it's in Windows because I'm not using, but I believe there must be also some kind of Init. And most of the Init systems in Linux are also can be ported to the FreeBSD, by the way. So going back to the question why Init in MicroPython. So the first, like, the reason to do this is why not. And after why not answer, I was thinking kind of a little bit about another reasons to develop the init system in MicroPython. So I was feeling a little bit like this. In the hijacker's guide to the galaxy, there was this big computer called Deep Thought, and the task for this big computer was to answer for the fundamental question. So the question was about the sense of the existence, universe, and so on. So I was feeling a little bit like this while thinking about doing init system in MicroPython. So in this presentation, I will tell you what reasons I have found to work on this project. And before we start, so let's have a look on the theory. When you press a power button on a computer, there is actually pretty much things going on. So the first, after pressing the power button, the first software that is run is the firmware. The firmware is located in a chip on the motherboard. Then the firmware is responsible to scan the devices and to find the storage devices, and then to find the bootloader. Bootloader is responsible to display the boot menu. So this is like the most popular is the group, and it's responsible to find the kernel and to load the kernel. So then when the kernel is loaded, the kernel in most cases loads also the init ramfs, which is a small operating system that is responsible to figure out what drivers are needed, if the disks are encrypted, and so on. And after init ramfs finish the job, then the control is taken to the init system. So in general, there are these 5 points. And also notice that bootloader nowadays can be skipped because the UEFI can load the kernel immediately, what was not the case in the past. And also initramfs can be skipped. And initramfs it was created in 2012, around 2002, to make Linux distribution to make Linux portable. So like one distribution can run on very different hardware. And before we continue, let's do a little experiment. So this is what I will do. I will set up in Linux kernel, there is the command line, and this command line can be instructed. So do you see? Do you see the text? Okay, great. There is the init parameter, and this init parameter can be used to tell kernel which init system should be loaded. So now I have changed to bin bash. So one moment. Okay. And this is actually also the trick. Like if you have the Linux distribution and you have forgotten the root password, the way to reset the root password is to change the init system to bin bash in bootloader. So then the kernel is not loading init system, but is loading directly the bash. So the bash runs in the case with the root privileges. And so this is the way to reset the root passwords. And here, like we have the virtual machine, and in this virtual machine we have loaded kernel that loaded the bin bash. And now you can see, for instance, that there is no network in the setup because it is like pure kernel and no drivers, no initialization, and actually nothing at this case. So like there is no network. There is a face system that is mounted as read-only. And also we can check the PID. You can see that bash is running with the PID1. So this is like PID1 is reserved for the init systems. Okay. So now let's continue. Init system has pretty much stuff to do when it's loading. So the first, it has to mount essential file systems. It has to check if the file systems are correct. It loads additional Linux modules, prepares the hardware to be ready, prepares the network, starts the services that are required, and also prepares the system to be ready for users. So it is responsible for the login prompts. When the system, when the init system is, when the computer is shutting down, the init system is stopping the services in the reverse, more or less in the reverse order than it has been started. And also, when it comes for the modern init systems, such as systemd, modern init systems are also do start services in parallel, so the computer starts much faster because it's not waiting for network, for instance, and also provide the logging, timer, and the services that in the past has been reserved for the separated programs, for the separated daemons. And also it is responsible for monitoring services, like to check if the system is alive. When it comes for the init system landscape, like the landscape is dominated by systemd. Systemd is very common on the servers, in the cloud, on Linux desktops. And then we have another init systems such as OpenRC, sys5 init, runit. Runit was in the past used, promoted by Ubuntu, but then they have changed to systemd. And also we have S6, and I think personally that S6 has the big potential to grow, because it would be great if there would be more if there would be more strong init systems in the landscape. And the common thing for the init systems, like for these init systems presented here, is that all of them are developed in C. And C is because init system must be light, and also it must be fast. In the sense, in Python we have the virtual machine, we have the garbage collector, we have the GIL, and so on, and it makes the response. It makes that the response might not be immediate, and the response, like, there is no guarantee that the system will respond every time in a certain amount of time. So it's not deterministic in that sense. But still, why not to try this in MicroPython? Okay, so as I have said, like MicroPython is optimized for the small devices, so it is light. And if you compare the amount of like the size of the projects, so the CPython, like the standard Python implementation that is CPython, is 1.2 million line of codes, while MicroPython is much smaller, that is 70 kilobytes of code, of line of code. And in MicroPython, everything is simplified. So in general, MicroPython is keeping the it is compatible with the CPython, but actually all modules are simplified. Some are missing, but actually you can do like pretty much in MicroPython. And MicroPython is of course the word of the devices. So like it is used to program devices such as, for instance, you can build devices for the Internet of Things based on using MicroPython, microcontroller, and the peripherals. And the way the peripherals, like the way the microcontroller talk to the peripherals is the GPIO port that is usually on the edge of the device. So in this case, this is ASP32, and here, like I have marked in red where the GPIO ports are. And MicroPython comes in the form of ports. So for each, depending on the electronic board that you have to find the proper port, and then this MicroPython port is loaded to the microcontroller as the firmware, and then MicroPython virtual machine is responsible for compiling the code and running it. So in general, when you do the development with MicroPython, you have to have the running, you have to have the microcontroller board. So like the code execution, the bugging, and so on is happening on a board, and the computer is only for the IDE for writing the code only, not for executing. And there is a special port of MicroPython that is called Unix port, and this is the MicroPython virtual machine that is run in Unix environment. So this is very interesting in the context of making the init system in MicroPython. And also it is good to mention that when you play with Internet of Things, you have, of course, these small, tiny microcontrollers, but also there are the much bigger boards, that is Raspberry Pi, and these boards can be used to also to make the IoT projects. So again, like it has the GPIO ports, so it can be used to connect different sensors and peripherals. And on the SBC you can run the Linux, of course, because it is a much stronger device. And yeah, going back to the question, why init in MicroPython? So the first thing that has come up to me is that it would be great to make the web console, because when I was developing when I was doing different projects from the from the realm of the Internet of the Things. There is this boring work of there's the problem with to initialize the device. So I mean, here it would be nice to have the web console integrated with the init system, so you don't need to SSH to the device. You can just connect to the web console, and in this web console you can configure the device in the way you want. So this is about the speed and efficiency. And also in many devices or in many systems such as this, there is the default username and default password. So in general, default username and default password is not a good idea. So much better idea is to have the device that after boot time is waiting for, let's say, first 5 minutes for user to log in with no password, and when the 5 minutes is passed, then the device is not accepting any logins. So it makes much more sense from the security point of view. So this init system would be extended by the web console that would be expecting for the first connection with no password, but for the first 5 minutes, so let's say. And yeah, but of course, if you do engineering, problems are things that always come. So init system must work on root privileges. It works as PID1, so PID1 must be the root process. And of course, it is not good to open the sockets, network sockets on as root. So in this case, actually, this init system would need to be split to 2 parts. One would be the part that is responsible for executing the services, and then there will be another part that is running on low privileges that has the implemented logic and the web server. So this is like the plan when it comes for the development of this init system. And another reason is that in the case of many devices, it is pretty much often enigmatic what the problem is. Meaning, let's say you have the device that has no keyboard, no display, but just the diode, and just guess what the blinking diode is. So the nice solution would be to bring a small display, and this small display would give the exactly what the problem is with the device. So I see here that another potential application for such a init system, and but there is also another problem with that, because as you know, both Python and MicroPython are great for the projects that utilize the hardware. So both in MicroPython and Python, you can write the drivers to handle the small display. So you can write the program that will that will display something on the small display, for instance. But it works in a very different way. Like MicroPython is designed for the microcontrollers, so that means that when it talks to GPIO ports, it is talking directly to GPIO ports. But when in the case of the computers such as Raspberry Pi, the communication with with GPIO ports is reserved only for the Linux kernel. So, like MicroPython, when it's run on the Raspberry Pi, is not able to talk to GPIO ports because, like, there is not such an option in MicroPython. To talk to GPIO ports, there is the need to use the full Python. And yeah, so the hardware, like integration with the hardware, is problematic, but making the web console for managing the init system is pretty relatively easy to do. And of course, by writing the init system in Python, we can use the power of the object programming. We can, so for instance, in init system is relatively simple. You know, you have the service and start the service, but you have the dependencies between the services. So one service must start after another. One service depends on another one. So there is this pretty complicated graph. So this is the logic that I think that is nice to implement in Python. And also Python is modular, which is good for the init system, and also it's cross-platform. Cross-platform in the sense that it can run on Linux, but also on a FreeBSD. And yeah, so these are two reasons that I have found for the MicroPython. And so now I will show you what I have been done so far. So I have developed a prototype of such a system. And for the development, I use the virtual machine. And because the project is meant for the Raspberry Pi computers, so I use emulated Raspberry Pi. Okay. Init. Okay, so now, I have launched the virtual machine. The kernel has loaded, and now we're waiting a little bit, and then the MicroPython. Oh, now the MicroPython took the control, and now it's loading the services. Okay. Okay, so now we have jumped to the bash, and now you can see that there is the network, there are the kernel modules. So in general, the system is operating. So there's also a drop beer. Yeah. Okay, so. Okay, so the goals for this init system are to make the init system dedicated for the SBC boards, and the goal is to make it. Actually, the most important thing that I have found when setting up the Raspberry Pi computers is to make the system that will automatically handle the SSD trimming. Because like to have the flash card to live for long, actually you need to trim the space, and it is not always by default. So it would be good to have the init system that will ensure that that flash space is trimmed. And also, when it comes for the computers, like single board computers, not always time is available, so you have to ensure that the time is set from the network. So the init system would also handle these tasks. And yeah, and one more thing, I have developed the Linux distribution that is based on the Alpine Linux, and this Alpine Linux distribution is featured with automatic installation. So meaning like to run the system on the Raspberry Pi, you have to copy the image to the SD card, and then put the SD card to the device, and then boot the device. And what I have done, I have developed the distribution that automatically does automatic installation. So you plug in the SD card to the computer, then the computer boots, and then it automatically expands the file system, does the basic initializations, and so on. So this is very nice because then I can skip a lot of boring stuff like partitioning the disk, and actually I don't need to waste the time on doing the setup manually. So here's the QR code to this distribution that I have developed. Okay. So here is the QR code to the MPy init project. So, like to summarize, this init system is designated for the single board computers and in general Internet of Things. And yeah, so it would be that's it for the presentation. So welcome for any questions.
Yes, any questions? Yes, we have questions. Thank you.
After I boot your Linux distribution that uses this init, how can I interact with your init system? Can I just log in into Python REPL and do some interaction, run additional services using it, or is it impossible now?
It opens the bash, so you can interact via bash, and this is it's based on a BusyBox. So what this init system is doing is loading the services that would be normally loaded by BusyBox. But of course, also I'm planning to do some integrations with the MicroPython, so some services might be developed in the MicroPython and load that straight from MicroPython.